Aloha Meteorology, Mr. Mack here. So this week I want to spend some time just kind of talking about the tropics. We've been talking about El Nino, La Nina. We've been talking about ocean currents, tropical cyclones. So that's kind of what I want to spend some time on this week. So let me jump down here, share my screen. Perfect. So now you should be seeing the notes for our hurricanes right here. Now, a couple of things. Now, in the Eastern Pacific and the Atlantic, they're called hurricanes. When you get out to the Western Pacific, we call them typhoons. Sometimes you hear them referred to as tropical cyclones. It's all the same type of storm. So there's nothing different about them other than the region that they're forming in. Now, you've got to have water at least around that 78 to 80 degree Fahrenheit. Got to have really warm water. Warm water is like high octane hurricane fuel, all right? When Hurricane Katrina blew up in the Gulf of Mexico, the water temperature was like 98 degrees. It was so warm. Not much energy had to be added to that water to cause that uplift to form those thunderstorms. So you got to have that. You got to have stable air at the mid-level so those thunderstorms can continue to build and build and build. Each one of those thunderstorms are a low pressure system, so they start coming together and grouping around a common low and forming over the warm water. As long as you have that warm water, you also have to have warm water relatively deep, okay? Like it says here. Yeah, to a depth of 150 feet, because you have all that upwelling, bringing up that warm water to fuel it, and eventually cold water comes up, and cold water is hurricane death. All right, you don't want cold water for your hurricane. Now, the other thing to notice here is it talks about 300 miles from the equator. So 300 miles north of the equator, 300 miles south of the equator. Storms won't travel from north to south or south to north because the earth is rotating really quick at the equator, 1,000 miles an hour. So you get upper level wind shear. Actually at the equator, you don't get really long lasting low pressure systems. You get afternoon thunderstorms. You get your thunderstorms and then they die out. And the next day you get thunderstorms, that convection. So talk about the season. Well, we're almost there, all right? So right here, the Atlantic hurricane season, the Caribbean and Gulf of Mexico is June 1st to November 30th. So we're about a month out. You know, we're at the end of April, beginning of May. We're about a month out from that first June 1st for hurricane season there. But in the Eastern Pacific, meaning the west coast of the United States, the west coast of North America, Mexico, a tropical storm season starts May 15th. We've actually already here in 2020 already had our first disturbance. So it could be a potentially active tropical cyclone or hurricane season down there in the Eastern Pacific off the west coast of Mexico and even in the west coast of the United States. So then the Central Pacific, so what we talk about is like Hawaii, that area, June 1st to November 30th. In the Southern Hemisphere, there we go. We're actually coming close. What's today's date? Oh, yeah, there we go. Today is April 30th. We're on the last day of the Southern Hemisphere tropical cyclone season. So think opposite, you know, our seasons are opposite because of Earth's tilt. So they are in their fall, they're ending their fall and they're going into their winter while we're ending our spring going into our summer. So theirs starts November 1st and ends April 30th. So wanted to kind of show you that. So the things that we're going to look for when we look at satellite imagery are groups of thunderstorms in the tropics, basically from around the equator to 23.5 degrees north and from the equator to 23.5 degrees south. We're right on that fringe, that border between both cyclone seasons. So let's see if we got anything. So you're all familiar with this map here, kind of the global satellite map. Let's see if we can zoom in a little bit more here. Perfect. So right here is the equator. You can see my cursor going across there. If we come over here, there's the Ecuador, the Galapagos Islands. Notice how it's pretty clear along the equator, all right? Now here in Africa, you do see some thunderstorms that are forming. You get the thunderstorms that build up during the day, it rains, lightning, thunder, and then they die out. So you can almost see where daytime is and nighttime is based on the convection. So you have some convective action here along the equator in the Amazon rainforest. And then you have your really nice dominant low pressure systems here in the mid latitudes in the southern hemisphere. And then your nice dominant low pressure systems here in the mid latitudes in the northern hemisphere, okay? But when you look at the tropics, so from here to about where Hawaii is, Hawaii sits right there in the tropics, you look for any grouping of thunderstorms in the ocean. And when you look around the northern hemisphere, off of Africa is pretty empty. You get thunderstorms that come off of Africa because the dry air off the Sahara meets with the warm water here, and then they build and can form hurricanes. Same thing here in the Caribbean, here in the Gulf of Mexico. Not a whole lot of action right now. We look here in parts of the northern part of the Indian Ocean. You get storms there, nothing really there. And then you look here. Now, there is this group of thunderstorms here coming off of Indonesia. This is Indonesia. This is India here, Sri Lanka. And actually, we're gonna do that just a little bit more. If you look at the way these thunderstorms are grouping together, okay, and they're trying to do something. But the problem is the equator literally is like right here. So if these thunderstorms move northward, we could see tropical cyclone development. If these thunderstorms here, south of the equator, move a little bit further south, we could see some tropical cyclone development. This right here is a very active area of thunderstorms, and you can kind of see that the wind shear trying to form something. You can kind of see that clockwise here, but it's really close to the equator. So doubtful that anything will happen, but we'll keep our eyes on it for sure. We come over here, Japan, nothing there. They get tropical cyclones. Fiji in the southern hemisphere, not much going on there. Nothing down here by New Zealand. Now the northern part of Australia can get some. You can kind of see that clockwise rotation here. Southern hemisphere, lows go clockwise. So this might turn into something. You look at this thunderstorm here, really pop up near Papua New Guinea. Really pops up nicely, but there's not a lot of space for this to build. Land will also take out a tropical cyclone. We come up a little bit north, and there's another really nice group of thunderstorms. So here you have the Philippines, all right? So the one thing we need to look for here are groups of thunderstorms and rotation. Right now, we don't see any of this. In this case, we're north of the equator now, counterclockwise rotation. So we see some groups of thunderstorms. There could be some counterclockwise here. There's lots of convective energy, so we know the water's warm, but we don't see anything really organizing yet. So two areas to keep our eyes on are this area here and this area over here in the Indian Ocean and over here in the Western Pacific. So we'll keep our eyes on those sections. This over here kind of looks like it's trying something, but again, we are in the end of the Southern Hemisphere tropical cyclone season, and we're at the very beginning. We're like almost, we're like in the pre-season of the Northern Hemisphere tropical cyclone season. So we're really looking off of Mexico right here and Central America, and we're looking to see if these thunderstorms group together to start that area of counterclockwise rotation. So actually, if you're studying oceans and hurricanes at the National Hurricane Center, you're looking here. You're maybe keeping an eye here, right over here in the Pacific, and then again in the Indian Ocean. Now, if we go and we look at what's going on here, or look at what analysis we have, we go over here to the National Hurricane Center, and this is where they keep track of our storms. So right now, there's nothing, no warnings. It's a blank slate here, nothing going on in the Atlantic, Eastern Pacific. Yeah, even where that little group of thunderstorms was right here, it's really not bringing up any sort of watches or warnings or anything of that sort. Central Pacific, nothing. So it's not even that season. They got some general pressure systems and fronts coming through. But again, now if we look at our ocean temps, we know that we're kind of in that in-between season. What we're gonna look for here is we're gonna look for the Gulf of Mexico to heat up. We're gonna look at this warm water current coming off the East Coast. really good warm water here off of Mexico. These are the areas that we're going to look for hurricane development now. Now, as the season goes on into August, September, October, November, we start looking here off of the west coast of Africa. And we also we still keep a good eye here because it's going to warm up. You can see in the Indian Ocean, the water's still really nice and warm, but you got to get those thunderstorms. Same thing here over by the Philippines and Papua New Guinea in the Western Pacific. So the water it's warm, but we need the thunderstorms and the convective uplift. Now, let's take a look here, North Atlantic. And this is an important map to look at because here you can see those warm waters along the East Coast. This is why the East Coast gets the hurricanes and the West Coast doesn't. So you have water here right now that's in the 70s, pushing the 80s. Later on in the hurricane season, we'll see a lot warmer water here. So right now, nothing, no active systems. Eastern Pacific, no active systems. And notice how it's opposite of what we see in the East Coast, okay? Cold water here along the ocean in California. If you've ever been to the beach, you know the water's cold in California. We're talking 50s, 60s, and that water's coming down from Alaska. But it's here. Look at that pocket of warm water right there. We're probably pushing to the upper 80s here. That's where we're starting to see a little bit of development. So they're keeping an eye on there. This is where hurricane season is the earliest in the Northern Hemisphere, around May 15th. So you have some areas we're keeping an eye on, watching the water. Now I wanted to show you this too. This is, oh no, do I not have it here? All right, so a really cool website is called Earth Observatory. And Earth Observatory shows a lot of really cool images, the satellite images and data. And I'm gonna let this load up, but this shows us how ocean temperatures change over seasons. So we're gonna let that load up a little bit here so we can enjoy it. And let's go over here to tropical cyclone names, because everybody always wonder, how do these hurricanes get names? Well, there is a group of meteorologists that get together, and since 1953, the World Meteorological Organization has been getting together to come up with the names. So here you go. You have the history of names and how we got these, why we have certain names that are retired, okay? So let's look back here. 2018, Florence and Michael are the last two to get retired. If a storm is devastating and bad, when it comes to the amount of dollars in damage and life, the storm gets retired. So 2009, no retired storms. 2006, so very chill, not very active seasons, but 2005, Dennis, Katrina, Rita, Stan, Wilma, all intense hurricanes. And those names will never be used again. So kind of interesting, and you can read all about that history. But so what do we got this year? The first storm will be Arthur. And this is for the Atlantic. So the Atlantic hurricane season. We have Arthur, then Bertha, then Cristobal, Dolly, Eduardo, Faye, and it goes all the way down to Wilfred. Now in the Atlantic, we don't use Z and X because there's very little names. But what happens when we get to the end? Well, that happened in 2005. They go to the Greek alphabet, alpha, beta, and so on. We actually we got pretty far into the Greek alphabet that year because we had so many storms. Now that's the Atlantic. We go over here to the Eastern Pacific. Here we go, 2020, Amanda, Boris, Douglas, Eldo, Fausto, Genevieve. So we see these names. Now they do go into X, Y, and Z. Xavier, Yolanda, Zeke. And then future years you have Xena and York and Zelda. Better find the Master Sword. All right, so there you go. And then Central Pacific, so around Hawaii. So Polynesian-based names. So we do get into that culture. Actually, if you notice here with the North, with the Eastern Pacific, you see a lot more kind of Hispanic or Spanish names because of Central America. So if we come down here, we can actually get into some other basins. Other countries will name their tropical storms. Tropical storm could actually have two names. one area like the Philippines may call it one name, but Japan may call it another name, and the National Weather Service may call it another name. So depending on the basins, they could actually get different names. So let's jump over here and look at some of the names that they're going to use in India. So Bangladesh, India, Maldives, some pretty interesting names there. And again, it's kind of fun when you look at them. It is cultural based to give those names. So that's how they get the names. You have committees that come together. The storm's big and powerful. They'll actually retire the name. Now, let's jump over to my sea surface temperature map here. I love this because when you look at it really fast, it looks like our ocean temperatures dance. Well, the reason why that is because the Earth is tilted. You have the warmer waters, like here, for example. Let's actually go here to February 2019, and then you can start seeing in August, in July, August, September, the water's the warmest in the northern hemisphere. That's peak hurricane season, okay? But then you come down here into the winter time, like January, February, you can see the water's the warmest in the southern hemisphere, like in that March and April time frame, when our water's the coolest because it's wintertime, and the water's the warmest in the southern hemisphere because it's summertime, because of that tilt of the Earth. So that changing solar radiation actually causes a change in ocean temperatures, and as we revolve around the sun, it moves, and that affects ocean currents. It's phenomenal when you think about it. You know, in our winter time, let's go here to like January. Actually, when our water's the coldest a little bit later, so like January, February, get into some of our snowiest months like March, you can actually see how far south the cooler water is. And that's when we get those powerful low pressure mid-latitude cyclones for our snow, but that's when they get their big tropical cyclones in the southern hemisphere. Now, there is one region I want you to pay attention to, and it's right along the coastline here of South America. In some years you can see that it's really blue and purple. That's cold water. That right there would be an example of La Nina. That cold water coming along the west coast of South America and throughout the tropics. That's upwelling of that cold water, bringing in plankton, good fishing. Now what's interesting we found is when the La Nina happens, we don't have big tropical cyclones in the Eastern Pacific. We also get less snow. So here in the West Coast. But what we see is a very powerful hurricane season in the Gulf of Mexico and Caribbean. So La Nina has a powerful effect on the Caribbean and bringing in warmer water for the Caribbean and the Gulf of Mexico and the Atlantic hurricane season, but it shows us a weaker hurricane season. But when you go into El Nino, right here, look at this warm water right here, shutting off the cold water, keeping it low. Also fishing is not so well because the plankton and the food source isn't there for the fishermen. So the economy has an issue in South America. The water's warmer. Look here, the water's cooler. So when we are in an El Nino, we actually have a much stronger hurricane season in the Eastern Pacific. We see big storms, big snows in the west, but the ocean temperatures are cooler in the Atlantic and the Gulf of Mexico and Caribbean. So we have a weaker hurricane season in that area. And we're starting to see that El Nino and La Nina have a global effect. While one area could be getting pounded with tropical cyclones, one area could be in drought. And then it flips. One area could be getting flooded and the other area goes into drought. We can match the forest fires in Colorado with La Ninas and floods and huge snows with El Nino seasons. So it's not just a hurricane thing. It actually can affect global weather patterns. So it's, to me, just really fascinating to see how those ocean changes can affect our global microclimate patterns. And El Nino, La Ninas could last anywhere from 3 to 5-ish years. So if you look at our current sea surface temperatures here, we can actually start looking at what type of system we're in right now. So let's get there. And there we go. So the big thing we want to look at is what the water is doing off of the west coast of South America. and we can see it's relatively cool. I've seen it colder, but I've also seen it hotter. So we're kind of in that transition between La Nina, El Nino. That's why we've seen weather kind of all over the place, where we have these dry spells, but then we get pummeled with snow. And here it is, April 30th. Don't get too comfortable with these temperatures that are in the upper 70s and 80s. We could get pummeled by a late May or early May snowstorm, because that's what happens in these transition years between El Nino and La Nina, is weather can be super active. So there you go. I'd love to be there showing you this in class, but I hope that was helpful. I hope it kind of shows you how ocean temperatures and ocean currents can have a large effect on weather patterns and tropical cyclones. Hope you guys have a great week. Mac out.